In my last algebra video, which you can view in the card above, I briefly explained the usefulness of algebraic equations and gave a couple of examples. But in this video, I'm going to explain how to simplify algebraic expressions through a process called collecting like terms. But there are a couple of definitions that I need to outline first. An algebraic expression consists of alphabetical characters and numbers that may or may not be linked together with arithmetic operators. Some examples might include the ones that I'm writing out here. But it's important to notice that expressions do not have an equals sign. If instead we have 2x plus 4y equals 9, we now have an equation. This equation has two expressions, one being 9 and the other being the 2x plus 4y. The important difference here is an equation has an equal sign. These expressions and equations are built up of terms, and a term is a number or letter on its own, or numbers and letters multiplied together. And any number that comes before a variable, like the 4 in the a squared example, these are called coefficients. So let me quickly summarize these definitions with an example expression. This expression is 2y squared minus 4xy. We have two coefficients, a 2 and a 4. We have a y squared term and an xy term and a subtraction operator. And this expression consists of x and y variables. Sometimes expressions can have a number of different terms with exactly the same variables, and these are called like terms. Let me show you some examples. So this example here, 2x minus 4y plus z minus x plus 8y, has two different like terms. The 2x term and the minus x term are like terms because they have the same x variable. The same is true for the minus 4y and the plus 8y terms. These are like terms as well because they both contain a single y variable. Another expression that has multiple terms that can be simplified is 3xy plus 2xz plus yx minus y. Here the xy term and the yx term are like terms because when you have any set of variables multiplied together, it doesn't matter which order you multiply them. In other words, xy is equal to yx. They have the same value. So here, let's say x equals 2 and y equals 5. If we plug these numbers into the variables above, we have 2 times 5 on one side of the equation and 5 times 2 on the other side of the equation. They both equal 10. So it doesn't matter which way around you have the variables. And that's why the 3xy and the plus yx are like terms. The next expression has two like terms, and the like terms here are the p squared terms because they have the same variables and powers. In the next example, we can see all constant terms are like terms as well. In this expression, the 4 and the 3 constants can be simplified because they are like terms. So let's go over some examples now of simplifying expressions by collecting like terms. And when we collect like terms, we're only interested in the subtraction and the addition operators. So in example 1, we have two separate like terms, the y term and the z term. And when we collect these terms together in the next step, we always do this in alphabetical order. So we collect the y terms first. And with the z term, we've got a 2 multiplied by z and a minus 2 multiplied by z, and this cancels out. So we end up with minus 4y. So as long as we can identify like terms within an expression, all we really need to look at is the coefficients within the expression. And we simply add or subtract the coefficients between the terms. In example 2, we've got 3 different like terms. And again, we need to order these terms alphabetically. And now we either subtract or add together these like terms, and we end up with 4l plus m minus 4n minus 6. This is a slightly tricky one because we have minus 7pr and plus 3rp, and they are like terms because it doesn't matter which way round we have the variables when they're multiplied together. But when we write out these terms in alphabetical order, I've switched around the 3rp variables so that they are in alphabetical order. And we end up with 2pq minus 4pr minus 3. Example 4, we have a very similar situation, but now we've got terms that contain 3 variables multiplied together. And again, we've got 2 different like terms here. The ABC term, or the CAB term, which are the same thing, and the BC term. And placing these in alphabetical order, we end up with minus 4ABC plus 7BC minus 2B. And finally, in example 5, we've only got one like term here, the B squared term. And again, we just place these in alphabetical order and add or subtract the coefficients, leaving the variables alone, and we end up with minus 2a squared plus b squared minus 3bc minus 3bc squared.